Hi there friends, my name is Osman Güngör. This video is my homework for Principles of Aeronautical Engineering in svas University of Science and Technology. The lecturer is Human Amiri. This video includes some information about PITOT tube. PITOT tube is very important for an aircraft engineer. As you can think, or you may not heard about that, PITOT tube is for measuring to airspeed with using the pressure formulas. I will give information with details in coming slides. Let's learn it with detail. Main question for this topic is what is a PITOT tube and what does it do? A PITOT tube, as I mentioned, is a device that measures the airspeed with using some formula and some identities. Mainly and basically, PITOT tube has two ports. One port is only measuring the static pressure, and the other port is measuring the static pressure, and additionally, it measures the dynamic pressure too. Uh, you can ask me how can we evaluate the dynamic pressure. In fact, there is a formula that measures the dynamic pressure. It relates with the airspeed and the density of the air. I will give it on the coming slide on the coming slides. Uh, Yes, I said that. This instrument is particularly important in the fields of aviation and hydromechanics. We are interested in aviation, so because we will be an aircraft engineer. The PITOT is essential for determining the speed of an aircraft or any other air or water vehicle. We will solve two questions which which is related with the PITOT tube, and we will measure the airspeed on this question. And there is a schema. This schema shows us that PITOT tube has two ports. As you can see, I will show it to you. Please watch it. This port is these ports measure the total pressure, which means P, P static plus P dynamic. P means pressure, and this port is only measuring the static pressure, and it is not related with the airspeeds, and it's closed. As you can see, there is a hole, and this hole come just only with this port, which measures the total pressure, and the other ports just have a hole. This hole is only measuring the static pressure. I will show how can we understand and how can we use this information to evaluate the airspeed. Structure of a PITOT tube. I mentioned it. A PITOT tube has two ports. One port measures the static pressure, and the other port measures the dynamic pressure plus the static pressure. In fact, it's not very complex system. It has a very smart idea. I will make it clear with giving a real example. For example, you have two glass, and you add this much water both of these glass. Uh, this is water, and after that you put these two glass on the table, and after that you just add some water with just one glass. For example, this glass, you add addition addition water uh, in this glass, and you want to measure the how much water I put or yes, I put this glass. You can do that if this glass has 300 milliliter water, and this part should have 300 milliliter plus the volume of water that you add after. So if you can measure the total volume of, or total, yes, total volume of this glass, you can say that uh, if I uh, if I subtract 300 milliliter from this value, I will get that I put this much water in this glass. It is the basic logic of the PITOT tube. PITOT tube dynamic pressure port. This is an open-ended tube that faces the fluid flow directly. It measures the dynamic pressure of the moving fluid. As I showed you in a schema, this schema shows the dynamic pressure comes into the port that which measures the static pressure plus the dynamic pressure. The static port just measures the static pressure, and the differential pressure gauge will give us the velocity with using the formulas. The working principles of PITOT tube. It has two basic ports, as I mentioned. You can see this is the formula. This is the basic formula. P total, which means pressure, total pressure, equal static pressure plus the dynamic pressure. This is the second port of the PITOT tube. The first port of the PITOT tube only measures the static pressure. This is a very good example that we can understand it better. This is the pitot tube, and we can say that this diaphragm measures the total pressure, and this whole thing measures the static pressure, and this is the static port. As you can see, there is a hole, and in this hole, the air in front of the aircraft came into these ports, which we called diaphragm. And as you can see, if your static pressure is 2, let's say 2, and also the static pressure on the diaphragm should be 2. Additionally, the dynamic pressure because of your speed. This is the main logic of the pitot tube, and we will solve some question about that. What formulas gives us the airspeed? This page is very important. Uh, as as an aircraft engineer, we should know the international standard atmosphere, which which is for evaluating the pressure density and the temperature with altitude. Uh, if you use this is international standard atmosphere, you can find the pressure, the static pressure. For example, if you are flying about 11 kilometers above the sea level, you should use the international standard atmosphere to find the static pressure at this altitude. It's very important for that. This is the international standard atmosphere when the lapse rate is not equal to 0. Mainly, the dynamic pressure formula includes the speed, and with this formula, the airspeed can be measured. The formula is, as you can see, 1 over 2 times rho times v square. The rho is the density of the air, v is the airspeed, and you should square it. To measure that, we should know or evaluate the air density at that altitude. To evaluate that, international standard atmosphere formulas should be used, as I mentioned. As you can see, this is the basic formula, and you can derive it. I will explain. P total equal P static plus this, as I mentioned, this is the dynamic pressure formula. It comes from that 1 over 2 rho v square. And um, if you leave the v, which is velocity alone, you can get that the v is equal square root of 2 times parenthesis p total minus p static over rho, which is very basic and very important formula for measuring the velocity. At the beginning of the video, I mentioned that almost all aircraft has more than one pitot tube, and you can ask why we have more than one pitot tube. It's very logical to have more than one pitot tube because sometimes your pitot tube can be blocked with because of some reason, and your pitot tube can measure airspeed falsely, and this can lead lots of this can lead a very big accident. In some conditions, pitot tube can be broken and can be blocked. So the aircraft are using more than one pitot tube to increase the accuracy. For example, if your one pitot tube get blocked and it is giving you some information, and your other pitot tube is not blocked, and this gives the true information. If you have more than two pitot tubes, probably if one of them is blocked, you can see that two pitot tube gives almost the same result, but one of them is very different from that. You can say that one pitot tube get blocked or broken, and the other two pitot tube is working. You can take the base values of the other two pitot tube. There has been some accidents because of that. For example, the Air France flights 447 in 2009. These accidents occurred because of the unreliable airspeed readings. This event shows us how important to use more than one pitot tube. Uh, as I say to you, it's very important to know the real airspeed of your aircraft. To increase the accuracy, we use more than one pitot tube. How can we evaluate the airspeeds? I showed this diagram before this page, and we can understand it better. This is the port that measures the static pressure, and this is the diaphragm that measures the total pressure, which includes the static pressure and plus the dynamic pressure. Uh, your aircraft is going in this direction, and the air came into your pitot tube with this direction, and so the diaphragm measures the dynamic pressure also. As mentioned, the tube has two ports, which I shot. The port which measures the total pressure has the same static pressure with static port pressure. It's very important to know that. For example, if you are flying at an altitude which has the pressure of, for example, 1 atm, in your diaphragm, you will also have the static pressure as 1 atm if your static pressure didn't get blocked. So it can be evaluated with the difference between these values. Uh, one of them is in the diaphragm, and one of them is on the static port. Between these values and using the dynamic pressure formula, which I gave you, it is the dynamic pressure formula is 1 over 2 rho v square. Rho is the density, v is the air speed. If we solve the equation about that, you will understand it better. Let's read the question. A glider is flying at an altitude where the air density is 1.225 kilogram per meter cube. So it means it's in the flying at the sea level, and the static port measures the pressure 95560 Pascal, and the other port, which we call diaphragm, and it measures the total pressure, measures the pressure 102452 Pascal, and the question asks us to evaluate the airspeed. As you can see, I wrote the formulas. We can use these formulas. I explained the logic where this formula came from. And if you use, you can square these two terms, and you can get this formula: v square equal 2 times p total pressure minus the static pressure over all over rho, which is density. And if you write uh, write the numbers uh, write the numbers in this formula, you can get V is equal 106.01 meter over second. We can use this formula to evaluate the airspeed. At some station, your um, your static port or the other port can be blocked, and we will solve another question which the static port get blocked. What if the static port blocked? Let's read the question. Consider a glider flying at 400 meters. When all of a sudden the static ports of the pitot tube get blocked due to some foreign object damage. The pressure at this altitude is 96610 Pascal. It's then descends to sea level, where it flies at a true airspeed of 25 meters over second. What is the airspeed indicated by the pitot tube driven airspeed indicator in meter over second? The 25 is the true airspeed of our glider, and at as you can see, at 400 meter, the static port is get blocked, so the static port is not changing. As you can see in this diagram, the static port get blocked. So as you can see, there is no other hole, and your static pressure at this port will be constant. It's not changing. But in your diaphragm, your static pressure changing. Also, you have the dynamic pressure. So in this situation, your pitot tube evaluates your speed falsely. We will see in coming page on the next page. Solution for the question: at 40 knot kilometer, I wrote it falsely. It's meter. At uh, four at 400 meter, the pressure is given us as we can see 96610 Pascal, and if it's blocked, as I mentioned, the static pressure in this port will not change. It will be constant, but on the other ports, which we call diaphragm, the static pressure is changing. In this diaphragm, at sea level, our static pressure is 101325 Pascal, which is came from International Standard Atmosphere. You should know that. Our density will be at the sea level, because we are descending to sea level. 1.225 kilogram per meter cube, and if our velocity is 25 meter over second, our dynamic pressure will be evaluated with 1 over 2 rho v square. If you do the calculation, you will get that dynamic pressure is 282.8 Pascal. It's the dynamic pressure at the diaphragm, while in the other port, which measures the total pressure, the value will be P total equal P static plus P dynamic, and if you do the calculation, pressure total pressure will be equal 101,325 plus 282.8 Pascal. To evaluate the velocity that indicated from the PITOT tube, we should use the formula for velocity, which I showed you before. And if we do the calculation, if we use this formula or total pressure as we evaluated, 101,707.8 Pascal, and the P static pressure, as the equation said, the static port get blocked. So the static pressure will be constant, which given in the equation, which is 98810 Pascal, and the rho, it's not P, the rho, which is density, is equal 1.225 kilogram per meter cube. As if we use this formula, our P or total pressure will be that, and our static pressure will be that. If we take the square of both sides, we can get that. This is the formula, and if you do the calculation, your velocity will be 91.23 meter per second. As we can see, there is a very big difference between 25 and 91.23 meter per second. We can say that it's very important to have more than one pitot tube, because it's very common that in some situation the static port or the other port can be blocked with uh, foreign damage. So we should use two pitot tube. As you can see, 25 and 91 point, uh, 91.23 is very different. So as I mentioned, the aircraft can make accident because of these values. Yes, dear friends, that's it. This video is for teaching you how a P2P works and why we have this device prepared by, as I said, Osman Güngör. My name is Osman Güngör. I am in the Department of Aircraft Engineering. Lecturer is Principles of Aeronautical Engineering, and the lecturer is Human Emery. Thank you for watching.